Good afternoon. This is Don Grosman. I'm Technology Advancement Manager and Entomologist with Arborjet. I've been working for them about 8 years now. However, I was also working with them while I was an entomologist down in Texas with the Texas Forest Service. So we've had quite a bit of history. I'm going to be, of course, talking about spotted lanternfly, and we'll brush up on general biology, some of the management options that are currently available, and then discuss and present some of the research that I've conducted over the past 3 years and plans for 2001 or 2021. Yeah. So the spotted lanternfly, Lycorma delicatula, is a hemiptera, so it's a sucking insect. It originated in China, and it came over, we think, approximately 2012. It was discovered in 2014 in Berks County, Pennsylvania. And since then, it has spread crawling of the insect, but there has been some movement via transport from the central location. So right now we have Pennsylvania, of course, New Jersey, Connecticut, Ohio, West Virginia, Maryland, and Delaware, all having established populations. The insect primary host, and I'll talk about this a little more, is Ailanthus, or otherwise called tree of heaven. This species of tree was actually imported from China as well, but back in the 1800s. And since then, it has spread throughout much of the East Coast into the Midwest states. And based on our knowledge of their suitable life cycle development temperatures, as well as the host plants, we have, they've created a model and subsequently a map that indicates the potential range of spotted lanternfly potentially in the future. The red area, of course, is an area that is most optimal for this insect's development. So throughout the Midwest and up the eastern seaboard, as well as potentially some areas in California. So this insect is a generalist predator, i.e. they're preying on plants, and a number of important species are being fed upon. Of most importance probably is grape, hops, as well as roses, and then we have several different tree species. Most commonly attacked are walnut, maple, at least 2 species of maple, silver maple and red maple, as well as different species of willow and birch are the primary hosts of this insect, at least in the United States. There is some research that indicates that overall this insect is capable of either feeding on or laying eggs on 170 plus species of plants. So again, very general feeder, capable of taking nutrients and developing on different hosts. As I mentioned, the most important and probably primary host is tree of heaven. Again, this is found throughout the East Coast and has been very instrumental in allowing this insect to develop and expand in many locations. The insect has an incomplete metamorphosis or incomplete life cycle. It has nymphs that then transform into adults. The nymphs tend to look like the adults, except that they don't have wings. The eggs are laid generally in October, and they hatch out in May. And then there's 4 instars of nymphs that develop over the course of a few months. And then the adults begin to emerge in July, August. They eventually mate and begin laying eggs in September, October. Why is this insect such a significant pest as of late? Well, it's probably one of the best invasive insects. It has several characteristics that make it have the ability to increase in population and move to different locations. Again, it has a wide variety of hosts. It's quite mobile, particularly in the nymphal and the adult stages. There's very few predators, parasites, competitors, or diseases that affect this insect, so it's not going to knock down populations. Other predators like birds and mammals find them, spotted lanternfly, quite distasteful, and so they'll only try it once and then they'll avoid it thereafter. So thus, for all this, the populations have essentially gone unchecked. And since the female is able to lay upwards of 30 to 40 eggs, maybe even in 2 or 3 different sets of egg masses, there is the potential for population explosion. This is perhaps assumed back in 2012 that there was 1 or 2 egg masses that produced a small number of females. They reproduced, and then subsequently, so on and so forth. So as of this year, quite possibly there's the potential for 2 trillion females having been produced over this time. So again, very little to keep the populations in check, and therefore the populations are exploding all over the place. Significant problem, largely this insect is a nuisance. There is some damage to certain crops that I'll mention in a bit, but more it's a nuisance pest. Because of the large numbers of adults that congregate on trees which they feed, or they congregate on buildings and vehicles and other things like that. This insect, again, it's a sucking insect, so it feeds on various plants, including as it becomes an adult, it's mostly feeding on trees. And this insect feeds constantly, and it's sucking sap, and it has to expel the excess. So what you get is honeydew raining down from the trees, and the honeydew then serves as a medium for sooty mold. And so over a short period of time, all this honeydew is producing a large amount of sooty mold that prevents photosynthesis of plants on the ground. It's a major nuisance around homes and buildings and cars. And so it's a major nuisance. Another important problem, at least for spotted lanternfly, is the fact that it loves grape. So the vineyards are being severely impacted in Pennsylvania area, and several vineyards have gone under because of the mortality of vines from their feeding. In addition, this insect, through its feeding, will create wounds and infection points. Here we see on the right is a yeast infection that has developed as a result of the feeding of these insects. So, first through third instars will readily feed on succulent plants. They're very fond of rose as well as other perennials and annuals. They don't have very strong mouth parts that can pierce tough tissue. So they're focusing again on succulent tissue. They can also feed on trees, but they'll focus at the ends of the branches and on the leaves. As they continue to develop, as they move into the third instar, or fourth instar, excuse me, the red phase, they're able to move back to the trees and begin sucking sap through the bark tissue. Often they're on the trunks as well as up into the branches, but because of their larger size, they're able to penetrate through the bark and draw sap directly. This is generally a host timeline where they're feeding on certain species of plants at different times of the year. Initially, with young instars, they're focused on, again, roses, grapes, tree of heaven, but on those succulent tips and leaves. For grape and tree of heaven, they will feed on these species throughout their development period. Very favorable and preferred hosts. Others, like walnut, birch, willow, sumac, maple, they're not fed upon until later in the summer, again, because of the size and their inability to penetrate tough tissue. So black walnut is another favored species, but their leaves senescent very early. So once the leaves drop from walnut, they become unattractive to the insect. So within just a couple months, you won't see them feeding on walnut. But then they'll move on to other species such as birch, willow. They are later in the fall, they're quite fond of maple, in part because they retain their leaves well into the fall period, and the tree is still has flowing sap that they can feed on. So, some of the management options that are recommended by Penn State, Pennsylvania Department of Agriculture, and a number of the researchers that have been working on this insect. As we know, the tree of heaven is a primary pest. It was initially thought that this was a species that was required for development and completion of its life cycle. But it turns out through research that we've determined that it can complete a life cycle on other hosts. But again, it does prefer tree of heaven. With that in mind, and the fact that this is an invasive plant species, removing the host from areas is one option for attempting to control or reduce population levels in an area. The insect lays eggs on many different surfaces, particularly later in the fall. They frequently lay eggs on trees, but also other hard surfaces. So if you were to scrape off these egg masses into alcohol, you are providing a level of control. One of the problems is that this insect will lay eggs very high into the canopy of a lot of trees that you can't access. So you're doing a limited amount of control when it comes to scraping eggs. It's more of a psychological benefit than actual reduction in populations. Another option is tree banding, sticky bands or traps that are placed on trees that can catch nymphs and adults that crawl up the trees. Again, there are a huge number of nymphs and adults flying around in certain locations. So the bands can be somewhat effective in removing some of the population, but overall, because only a few trees are usually banded, the overall effect on population is somewhat limited. Another thing that some of the states are attempting to do is, of course, trying to slow down or stop the spread of this insect to uninfested areas. And so Pennsylvania, New Jersey, and here are some of the cultural options that I mentioned. Apologize. Again, removal of tree of heaven. Be aware that this tree puts out a lot of sucker growth, so use of herbicides to stop or kill the stump is very important. Here you see in the middle, scraping egg masses into a cup of alcohol. Another option is, again, the sticky bands. You'll notice that the wire cage is often used nowadays because these sticky bands will actually capture other animals such as birds and lizards and frogs. So to prevent that, a number of people will also put these cages around the bands. I mentioned that they congregate around buildings and vehicles. It's very important to be aware of their presence and the possibility that they are congregating in areas that might eventually be transported to other areas. You can see on the left, the insect will congregate on buildings. It's really not known why they'll congregate in a certain area, but perhaps there might be some type of pheromone that draws them together. But at least at this point in time, it's not really known. Again, they will congregate on and lay eggs on a large number of different hard objects. You'll see that fence post towards the right, as well as a folded chair with a large number of egg masses. They'll congregate in many different areas, and it's possible if they're mated, they will lay eggs on vehicles. The middle picture shows an egg mass that I actually found on a shipment that came to Woburn, Mass. We had a shipment of one of our products, Triage, and one of the warehouse people noticed a couple dead spotted lanternfly on a couple of the pallets. And so we went through all the pallets and looked underneath, and lo and behold, I found one egg mass on one of the pallets. So this insect is very tricky. Trying to keep track of it and prevent it from moving on is very difficult. Here you see situations where the insect will live on and or lay eggs on nursery stock and or Christmas trees. You can see the egg masses, some of which, like in the lower right, are very hard to see. And then you have adults and nymphs that are occurring on other parts of the plant. So we've heard about a number of different instances where, unfortunately, adults, nymphs, or egg masses are being found on these trees that are shipped out of these infested areas. As I kind of started, Pennsylvania, New Jersey, Delaware, Maryland, and Virginia have all established quarantine programs or quarantine areas to try to contain the movement of spotted lanternfly. The programs require businesses and truck drivers and people who transport products outside the area to have training on how to inspect vehicles as well as product containers and things like that. Once they take the course, they'll get a permit that allows them to move, again, product materials past or outside these infested areas. So my understanding recently is that at least Pennsylvania has distributed close to 1 million permits to businesses and truck drivers as part of this program. I can't say how many have been certified in the other states, but I'm sure it's increasing daily. Moving on, chemical options generally for a lot of people is the last resort, but we are finding that in many cases, insecticide use is necessary to reduce the impact of this insect in different areas, whether it be around your home, on trees, ornamental trees, in vineyards or hop areas. Contact insecticides are definitely necessary. For the most part, as I indicated, contact insecticides are used for the most part to reduce populations in areas, to protect the crops, and again, to protect trees. For the most part, and I didn't mention this before, for the most part, spotted lanternfly is not capable of killing trees. They are capable of killing smaller plants or young trees, such as tree heaven or causing wilt on walnut. But there is the potential, because they're piercing these trees, introducing some diseases and things like that. We know that in vineyards, the insects will suck essentially the life out of the vines, as well as the sooty mold that they create from their honeydew will cause a change in the flavor of grapes that are being grown as well. So again, the need for certain insecticide use is essential. Contact insecticides, there's a number of them. If you're interested, you can go to Pennsylvania Extension. They have several fact sheets for homeowners or businesses and provide a list of some of these contact insecticides. As a company, Arborjet is more interested in some of the other treatment options, such as systemic insecticides or reduced risk insecticides. And then I'll talk about it a little more, perhaps the discovery of a repellent to keep spotted lanternfly off different targets. But for eggs, stylet oil or mineral oil has been used to a certain extent, but the best control I hear is about 70% reduction in egg hatch. We're looking at some other products and active ingredients, and hopefully we'll be able to find something that maybe provide better control of the eggs. So here I'm just indicating that for Arborjet, we're focusing on systemics, reduced risks, insecticides, some 25B actives that are minimal risk, categorized by EPA. And then we're also looking at possible botanical extracts from different plants that might provide either an actual insecticide or deterrence or both. So we conducted some preliminary trials in 2018 and found that, at least initially, Imajet or imidacloprid formulation was fairly effective, as well as a couple of other actives and products, azosol, which is azadirachtin, and Acejet, which is acephate. We initiated a more substantial trial in 2019, looking at different rates of Imajet alone or in combination with an experimental product provided to us by Syngenta, as well as azosol and Acejet. We're applying the injections through our QuickJet Air system, which allows us to treat trees or inject trees in just as little as 10 minutes per tree. Bowl and spray applications are made via backpack sprayer. Usually we're able to reach up as high as about 20 feet. We cover the whole bowl as well as low-lying branches. To monitor the effects of these treatments, we're looking at 4 different parameters. One is the number of dead insects that fall into an inverted umbrella or a plastic mat and then a second is looking at the number of live.
I'll have to do that if I see the rest of them, I guess, to do it that way.
We're looking at live insects on the lower 8 feet of the trunk and branches. Third, we're looking at the amount of sooty mold that is produced as a result of their feeding and dropping of honeydew. So you can see on the far left, the sooty mold that has built up on an inverted umbrella. Sometimes we'll also use these clear cups that we place or attach to the trunk. And you can see in that lower picture, the cups on the far right are just covered with sooty mold. Some of the mold is actually a ½ inch thick. So it gives you an idea of how much sooty mold is being produced as a result of their feeding. So, and lastly, we'll look at in the fall how many egg masses are laid on the lower 8 feet of the tree to try to determine whether or not the treatments are reducing egg laying or not. Just quickly, this is the initial trial in 2019. We see that experimental P product provided good kill of spotted lanternfly, whereas the other treatments, not so much. This asterisk indicates significant difference between the treatments and the untreated check, which is on the far right. So with regards to live, we're looking for reduced numbers. And again, we see treatments that contain experimental P, as well as Imajet alone and Acejet alone, did significantly reduce the number of live adults on the trees. Looking at sooty mold, we see that Imajet, either alone or in combination with experimental P, as well as Acejet, significantly reduced the amount of sooty mold being produced from these insects on the tree. And then lastly, the number of egg masses that are laid on trees was significantly reduced by experimental P, as well as Imajet alone and Acejet alone. So This is a summary of the significance of the treatments. You see that generally Imajet plus experimental P was the best treatment in that it significantly reduced dead, live, sooty mold, and egg masses. The double asterisks indicate that for that parameter, that treatment was the most effective. So experimental P and Imajet, or a combination, proved to be very effective in reducing populations and sooty mold on red maple. Taking this information, we initiated some additional trials in 2020. In addition, we add another experimental product from FMC. And again, we're looking at Imajet alone or in combination with AceJet, and then looking at injections of experimental V or spray applications of V and P. We're setting up trials both on red maple, again, which is an important ornamental, as well as Ailanthus. If we can keep Spotted Lanternfly off Ailanthus, which is the primary host, I think we have something pretty special. So again, we're going to set up trials to see how well we can control populations on Ailanthus as well. For the red maple trial, unfortunately, we didn't see much reduction in number of live insects on the trees, but we were able to significantly reduce or increase the number of dead, as well as reduce the number of egg masses using experimental P again, as well as we saw a significant reduction in sooty mold using Imajet and AceJet. With the Ailanthus trial, we see that Imajet and AceJet were the best treatments and significantly reduced these three parameters, dead, live, and sooty mold. You don't see the egg masses because generally Spotted Lanternfly, after initial colonization of an area, will not lay eggs on Ailanthus. The reason being is that this species of tree drops its leaves or senesce rather early, generally before they're ready to lay eggs. So understandably, you're not going to see many egg masses on Ailanthus compared to red maple. We are also interested in the ability to maybe reduce egg hatch of egg masses on different trees or surfaces and such. We've been looking at a number of different active ingredients. As I mentioned, versus botanical extracts, as well as some minor risk or reduced risk products. So we've set up a number of trials. We're flagging sections of branches. We then spray the egg masses between those flaggings. And then we come back the next year and look at egg hatch of those egg masses within that area. You can see down in the middle, an egg mass that was treated or actually it was untreated. And this is what you're going to see in the spring. The covering that they put on the eggs is cracked and beginning to disintegrate. You use a brush to remove that material, and you can see all the eggs, as well as how many eggs have hatched. You can see the openings in some of them. From just this egg mass, we see 22 out of 37 eggs have hatched, which is about a 59% hatch rate. And just based on that number, I'm sure it's probably an untreated check. And that's generally what we see, somewhere between 50 and 60% egg hatch on untreated eggs. We're hoping to reduce the numbers down to 0. Again, for 2019, 20, and we're setting up a new trial in 21. We're looking at different active ingredients. We're also comparing some of these experimentals to standard treatments such as the mineral oil or insecticide soap. For the trial in 2019, we found that the experimental L1 and L2, which were undiluted, were very effective in reducing egg hatch. L2 in particular did very well. I think it reduced egg hatch by close to 95%. The L1 was, I guess, a little less than 60%. One of the problems, though, is we were hoping that the diluted treatment, L1 dilute and L2, would be as effective or close, but you can see that there really was no difference in the diluted treatments compared to untreated checks. A concentrated treatment is unfortunately too expensive. So we decided to move on from there. The second trial in 2020, we see that experimental M1, M2, and a combination of O and M1 were quite effective in reducing egg hatch. You see on the right, the percent reduction. So M2 was best at about 82% reduction in egg hatch. You'll notice that the untreated check hatch rate was only about 30%. Rather very low. Can't explain why it was so low in that area. But regardless, the M2 treatment did fairly well. We also looked at that, or are you continuing to test that formulation into 2021. We set up a new trial this past fall. We wanted to look at to see if timing of the spray applications mattered. So we tried applying just as they were starting to lay eggs. We sprayed a second time in November after they finished laying eggs, and then we will spray again probably in March, just prior to them starting to hatch, to see if, again, the timing of application is important. Surprisingly, when we did the initial application, there were a few egg masses. You can see around 4, averaged about 4 egg masses per branch section in October. And then we came back in November and we looked at how many new egg masses were laid in that treated area. And surprisingly, all of the spray treatments reduced the laying of eggs on those branch areas significantly. You can see upwards of 99% reduction in new egg masses on that sprayed area. So there is some type of repellent effect that deters them from laying eggs on those surfaces. Very, very interested. As of course on the far right, you can see that there were a large number of new eggs on the untreated check areas. So pretty exciting. Another observation made is that one of the treatments, as we were spraying the treatment on the branches in October, we noticed that a number of adults that were in the area suddenly jumped away from the spray treatment. So it suggests that it's an irritant or a repellent in some factor. So we're going to be looking at that more closely in the coming year. And this is that one formulation had several different components. So we're looking at each of the combination versus individual components by themselves to see how or which component is maybe eliciting these behaviors. So we're working with Julie Urban and Tracy Lesky with the U.S. Forest Service. Julie Urban is with Penn State, and both of them have agreed to test some of these treatments in the lab on laboratory reared populations. So hopefully we'll find out shortly whether or not or confirm activity of these products. Another area that we're also looking at is the potential for using entomopathic fungi that are known to kill lanternfly. There's a Beauveria bassiana and a new one, Batkoa major, that are both observed to have killed adults. Our pathologist here at Arborjet is isolating these pathogens, and we're hoping that maybe we might be able to utilize it in some type of chemical treatment as a way of controlling adults as well. But that's infancy stage. We're just starting out that way. So an overview is that through these trials, we have found that Imajet alone, AceJet alone, or a combination of both are quite effective in reducing numbers on trees, killing adults, as well as reducing sooty mold and egg masses. The experimental products, we're still evaluating them. Hopefully we can get one or more of the companies something to keep in mind is that generally spray applications, spray or injection treatments are not really needed midsummer. The treatments are not really having much of an effect on the nymphs, nor are the nymphs really destructive. It's the adults that are feeding extensively, producing a lot of honeydew, causing problems in vineyards. So if you're going to make applications, we generally recommend early August so that the treatments have full effect when the adults are most prevalent. Again, we're looking at some different options as a way of preventing egg hatch. Hopefully we can find something that both reduces egg hatch as well as maybe find a repellent that may prevent adults from laying eggs and or try to eliminate them from certain areas around homes, on vehicles, on pallets, other things. So just an idea for the future. Again, we're looking at safer products, reduced risk, or minimal risk actives. Try to get away from some of the more toxic contact insecticides that are currently being used. And last, we're hoping that maybe down the road we might be able to isolate these fungal pathogens and maybe utilize them as a treatment. With that, I will close. I hope I was able to provide some information that was of interest. If you have questions later on, you can contact me via email.